Hey, hello, and welcome to the show. It is time for JP's product pick of the week, and we're all here. So thank you so much for stopping by. We've got people in our chats. If you're looking for chats, you can find them over on YouTube. Hello to Dave Odessa, Tackle the World. Thanks for stopping by over there. You can jump on over to our Discord if you're somewhere else that doesn't seem to have a chat. This is it right here. It is at adafruit.it/Discord. Hello, Liz. Hello, Thin Man. Thanks for stopping by today. We are back, so hope you enjoyed. If you celebrated Thanksgiving or just at least had some time off last week, and now we're back and better than ever. So what do we got here today? I have a new product pick for you, a really cool, useful, fun one, I think, and at a really nice price. We're going to give you a 50% off discount on it without a coupon code or anything. We just slash that price in half. It's available right now at that URL and QR code. Where am I pointing? Some of these places right here. Go to one of those. That'll take you to the product page for this week's product pick. This show is broadcast from within that page, so you can still enjoy the show and the product page simultaneously. It's as if picture-in-picture technology never left us. And what else? I'm going to have a demo for you. I'm going to have Lady Ada talk about the product pick. So without any further ado, let's have Lady Ada tell us about this one, and I'll be right back to you after that. Take it away, Lady Ada.
This microphone, which is by the code. We had a few people email us and ask for us to carry another MEMS microphone. So this is an I2S output mic, which means you can connect it directly to microcontrollers or single board computers without drivers, without like special kernel things, without I2C command writing, without PDM decoding. It's a MEMS mic, and no need analog input. It just spits out like true I2S data when you send it clock and left-right signal. Hook up two of them together and you can have stereo because one will transmit on the left side, one on the right side. It's the same pinout and shape as our SPH 34 something 628, but this is using TDK InvenSense's ICS series of microphones, which people really like. Again, very high quality, very easy to use, and pretty inexpensive. If you just need like a microphone added to your ESP32 or Raspberry Pi, and you don't want to have like a whole codec, this will do the job great.
Yes, nice and to the point. That's right. So this is the product pick this week. It's tiny. Can you even see it right there? It is the I2S or I2S MEMS microphone Breakout. It is the ICS 43434 element from TDK, and it is back ported. So all you do is plug this into your microcontroller that can support I2S or I2S and make sounds into that little port there. The element and the circuit on there, the integrated mic element, will take care of the rest, turning that analog audio signal into the digital signal that can be read on your microcontroller that uses the I2S. I think I'm going to call it I2S. I confused myself because I2S is what the Wikipedia article says. What is I2S? It's the Serial Interface Protocol for transmitting two-channel digital audio. So what's the benefit of this? Well, in some cases, you may not have an analog input for a microphone. You may not have PWM input for a microphone, but you want some really nice, clear, low noise sound, particularly great for voice stuff. These are used in all kinds of consumer products. We'll take a look at a data sheet and talk about that in a bit. But first of all, let's jump back to this page right here. Let me open up. Oh gosh, that thing broke. Hold on. Let me pull up a browser window here. Where'd you go? Google Chrome, come back. There it is. I'll take that off of there so you can see this is the product page for it. If I refresh here, we should see we have them in stock. We stashed 100 of them. We have them on discount for $2.48 right now. There is the mic. You can see, I'll show you another picture, but you can see the back ported mic right there. So it comes out of the back of that. You kind of solder it upside down, put it on your Breakout or on your, what's the word I'm looking for? Breadboard, permaproto board, however you want to solder that in. And if we take a look down below, we have a link to the guide here. If you take a look, we have some pinouts, info, assembly, and then there is a wiring diagram and some samples of using it inside of an Arduino environment. And right here, this is using a Feather M0 in this case, but this will work with SAMD21 based chips, SAMD51 based chips, ESP32, RP2040, RP2350. Should work with all of those. And you can use this with Raspberry Pis. It's a really popular use for this type of MEMS I2S microphone because you don't have an easy way to use analog on that or PWM. So I2S is a really nice way to get sound into your Raspberry Pi projects, either for sound recognition stuff, for straight recording of audio, for voice recognition stuff. So useful in a bunch of different scenarios. What I'll do is, let's take a look, since I mentioned it, at the photos there, nice high-res photos. You can see that we have the 3 volt. This is not good for 5 volt logic chips, but 3 volt, roughly around 3. Ground, we have the B clock, we have the digital out, the left, right, and the select. So you can, if we look at the pinout, actually I'll get these names right. Let me switch over to here for a second. Let's pop that up there. So you can see it has bit clock and the left-right clock, also known as word select. Those are the 2 I2S lines. Now the nice thing with this is that it is set up by default to be a mono left channel. If you use 2 of these, you can ground the select pin or set the select pin to high and indicate a left and a right, so you can get stereo sound all over one I2S line. So it's able to deal with the 2 of them. You just have to jumper that. And yes, as Toddbot just mentioned over in the chat, be sure to solder this upside down. That's the biggest oops I've made. The audio sound hole is what we normally think of as the bottom of the thing. So if you look in this nice high-res photo there, this is actually of the previous one. We have 2 different versions of this, both in the same Learn guide, but it's the same in both cases. We have that port underneath because that little MEMS microphone package is designed that way. And then if you take a look here, this I2S library that comes with Arduino works great for this, and that's what I'm using in this example. So let's jump over to my down shooter, and I'll show you what I've got set up here. Let me just tweak my exposure a bit to make that a little easier to see. There we go. So you can see here I've got I2S lines, power and ground, and the Feather connected here. I'm running it over USB, and that's because we want to see the serial output here. So I'm going to switch to Arduino here, and let's take a look at this code. What's going on is we're importing the I2S library, which can be used both for output and input and output of I2S sound, in this case input. We're using serial, which we've set up here, and then we're creating the object by saying I2S begin, I2S Philips mode. It's at 8 kilohertz, and we're doing 32 bits per sample. I think you can do 8, 16, and 32. There are more available with the chip, but I think in the Arduino library, these are the ones that'll work. This one works fine. And then in the main loop, what we do is we create a sample by reading the mic. That's it. That's the whole, hey, are you doing anything? Do we have any samples coming in? So I2S read. And then if there is a sample, then we're going to print that. And I'll show you a variation on printing that, which we can look at just raw values. That's not too interesting. Or we can plot that in the serial plotter. So that's what I'm going to do here. This is the serial plotter for the Arduino. And you can see as I'm speaking, you can see the waveform changing there. And what I wanted to do, since delivering on the promise of this goofy thing right here, I'm going to sing into this. And what I think is really interesting about this is you can use this for tuning. It's pretty precise. So I'm going to just try to sing a pitch and adjust the tuning until we kind of calm the wave down, just because I'm going to match the refresh rate of this plotter here, which is roughly like a G sharp or so. from experimentation. But I'm going to try to sing a pretty pure tone, so you should see a nice smooth sine wave. And then I like to try to practice overtone singing, where you kind of change the shape of your mouth and the position of your tongue to enhance a bunch of the harmonics and add other notes that you'll hear that you can pick out, or even just the difference between vowels as you sing them. You'll see that an A has a whole bunch of harmonics compared to an E or an O. So here we go. Enough. Let me get a sip of water here. Here we go. So here's. Oh, I want that to stop. Hold on. Okay, I'm going to try that again. I'm going to try to stop it when it's smooth. Okay, fairly smooth there. Now I'm going to try to rough that up, add some harmonics to it. Okay, so you can see there, now we're getting all these little added tones. I don't know if you can hear those over this little microphone here. I can hear them, but sometimes with overtone singing, it's also easier to hear it in your skull, your resonant chamber, than the open air, unless you're really good at it. You practice a lot. I don't practice much. But let me try that one more time to try to get a clean tone and then an overtone. Here we go. Okay, fairly smooth looking, but I've got enough of a rasp in there to get a little harmonic, and now we'll try to push that. And there you go. We see a whole bunch of little harmonics there, which were these little extra tones that we're hearing in the overtone sequence. So someone said in the Tackle the World in the chat, said, everyone sing now. Yeah, sing along with me. That's right. The challenge is the Tibetan throat harmonics. Yeah, I don't think I'm going to try those. But yeah, you can see, actually, I'll leave this running. If you, especially as I sing lower, you'll hear more grit and rasp and harmonics and things like that, and you'll see them. So that may be the same pitch, but you can see it's got a ton going on. Same thing if you do like a whistle in a sing. So I'm going to try to do sing a tone and then add a whistle to it. Unfortunately, I'm spamming the serial so much that it's a little bit delayed, so I'm going to just reset this. I don't have much of a delay there, so I'm throwing a lot at the serial port. Here we go. There we go. Little Santa Claus beards. So Neil Campbell asks, thanks, you can save me from this singing now, it's a little embarrassing. Can you record to a file and then play it back? So yeah, if you look at the Learn guide here on the left in the Raspberry Pi wiring and test, there is a sample code and there's install instructions because it's Linux. You're going to need to install some drivers and things. But there is an example of using a record and mixer, so you can record samples through this microphone onto your Raspberry Pi. So yeah, it'll definitely work for recording. I'm actually not sure if there's any examples of recording on an Arduino board. It seems plausible, maybe on Teensy. I wouldn't be surprised if you can use this mic with the Teensy audio library and a Teensy, a pretty fast one. But I haven't tried that, so I'm not sure. But if anyone knows, if anyone's got experience with this using I2S with a MEMS microphone to record into or sample and then play back on Linux or on a microcontroller, that would be cool. Let's see, Todd says, let me bring up the chat here. Yes, you can, of course, use just about any USB audio interface with a Pi. Right, so there's plenty of options out there. There's Pi Audio hats, and I'm guessing some of those use these little MEMS microphones, possibly over I2S. Let's see. Dave Odessa says, this is certainly get into the top 10 in the charts. Yeah. Thank you. All right. So one other thing I wanted to show, and it's actually got so many more harmonics that it's actually a little harder to see what's going on, but I have a little, let me bring up this view of the world again and bring Arduino forward. Let's hit that run. I've got a little synthesizer here, a little Korg synth. I think I need to power it down and back up to wake it up. So running this little synth here, which has a little speaker on it, you should see, right? So as I add filter or change the some modulations on the saw shape, that happens to be a sawtooth, you can see the change in the shape of the wave there. And then actually one other thing I want to show, so the, I'm going to stop that right there, the Arduino serial plotter is auto-ranging on Y. So right now we're just seeing the frequency of a wave that's sort of zipping by changing, but the amplitude of it is also available if we force the plotter to not auto-range. So I'm going to switch over to Arduino here, and I'm just going to uncomment a couple lines here. This isn't obvious from Arduino 1 to 2, essentially, IDE. Some changes, lots of changes were made, but some changes were made to the serial plotter that require you to kind of hack around with a JS file to get more than 50 samples. If anyone's curious about that, I can paste a link. But I also found a technique someone mentioned for trying to constrain the y-axis so it won't auto-range. So let me upload this to the board. And now what I'm telling it is essentially to plot three things. One is just going to be the number 60 million, and the other is going to be negative 60 million, which is roughly the range I'm getting from like spoken voice and song voice stuff. So if I stream those, then it won't auto-range. That's what that red and blue line are. And now if I talk real quiet or snap my fingers. So you can see actually, especially because I'm speaking to the live audience and I'm speaking a little louder than before, I should probably increase that range even more, because as I get outside of that range, you can see it does a little auto-ranging there. But that's kind of a neat hack there. Let's see if we can push that some more. Let's bring this up to 90 million and negative 90 million. And oh, there's some good discussion over in the chat, by the way, on Discord. If you're interested, C. Grover has some info on capturing a waveform and loading it into Synth.io, and a playground link for that. So that's, that could be very helpful. There you go. So now I'm not leaving that range, so you can see it's now, well, almost didn't. So I need a little more. And it's a little delayed right now, I think, just because there's so many values spamming at it in serial. So I'll try to hit stop here and relaunch the, oh, yeah, there you can see those are the serial monitor. I want the serial plotter. Bring that back over here. So there you can see both the pitch changing, the volume changing. And the little extra harmonics if you get a overtone into there. Let me restart that. And there you can see we got all these little extra bumps on there just from that overtone sound. So that's just one use of it. If you want to practice pitch and control with it, fun. If you want to build little integrated things that have displays on them, also possible. A lot of cool uses for this. Let's see if there's any other thoughts, questions, concerns, that is the URL if you want to go pick it up right now. It's should still be in stock. And whoops, now my browser is asking for me to sign in. I don't want to sign in. I just want to see the stock, oh, brother. Well, you tell me. Is it still in stock? Half price right now till roughly the end of the show, and then it'll go back up to full price. Still a bargain, $4.95 normally, I believe. And that should do it. So this, look at that little tiny thing. What's your name? I want to get it right. That right there. No, get out of the way. That right there, that's my product pick of the week this week. It is the I2S MEMS microphone Breakout. It's the ICS 43434. For Adafruit Industries, I'm John Park, and this has been JP's product pick of the week. Bye-bye.